This is the spider from the 24-inch telescope. So this goes at the sort of sky end of the telescope, and effectively it's these are the spider vanes themselves that mount on the side, and they anchor the central boss here, and then mounted to that is this. It's an old pulley wheel. In fact, John liked to make things from bits that were kicking around, and this is a picador pulley. I don't know what it's from, some sort of machine, a picador grinder, or I don't know what they used to make. Now, originally it had this big iron hoop round it, and the mirror itself was held in there with some metal plates. And this is made of steel. It's pretty big and heavy, so I want to really get rid of that, because any weight that you have at the far end of a telescope means that you have to have 4 or 5 times as much weight at the back of the telescope, so you need to get shut of as much as you can. This is aluminium, this is quite light, so I'm going to use a much more modern technique of mounting the mirror on here. I haven't got the mirror in my hand because it's wrapped up and stored away at the moment, but because I've just had them resealed. But this is the secondary mirror. It's an 8-inch mirror, or about 7.5 inch, and it fits on there just about perfectly. Now, the modern way of holding mirrors is to use RTV, which is, let me see if I can show you some RTV. I don't think I've got any around actually, but anyway, I'll do a video on gluing mirrors. But RTV stands for room temperature vulcanized silicon. RTV silicon, you'll see it called that, which means that you pipe it on, and at room temperature it then will vulcanize and become hard rubber, and it sticks like shit to an army blanket. It really is strong. When I made my Ritchie Chrétien, I glued the primary mirror on using RTV, and that weighs quite a lot. The guys some of the guys in the society said, "Oh, that'll never hold. Your mirror will fall off." Well, it hasn't, and I showed them a picture of a mirror. There's a mirror making facility that the Jet Propulsion Laboratories in America have got, and they make mirrors for big telescopes there. And there's a picture I found on the internet and a write-up where the piece of glass that they cast the mirror weighed something like, I think it was something like 14 tons, this mirror, and they stuck 6 pads on about this sort of size with RTV. I mean, there's quite a lot of RTV on there, piped in the RTV, and they stuck these 6 pads on, left them to cure overnight, and then attached the crane to them and lifted this 14-ton piece of glass out of the moulding case, which had taken about, I think it had taken a year to cool down, and they lifted it out, and they were suspending it on 6 pads that size, stuck with silicone, basically bathroom sealant. Very impressive, and apparently that's how they do them. And they also use RTV to stick the mirrors into the telescopes, and that's exactly what I'm going to do. So these are the collimation bolts which originally pushed up against the back of the mirror. So the mirror was held in by 3 other pads from the front, and then these were pushed up against the back to sort of rock it around. And one of the problems with that, of course, is it can deform the mirror quite a lot, because these are bending the mirror from behind, and any deformation in the mirror means that the lovely figure that you've put on it, the correction, if you like, the correction curve, gets distorted by these if you're not careful. I'm still going to use these, but what I'm going to do is I'm going to make some little aluminium pads, probably about the size of a 10p piece, or a quarter if you're in America, which I'll glue onto the mirror, and then I'll screw them into these bolts. I'll grind these flat so that they've got a little bit more clearance inside. I don't know what these threads are. I'm going to take them out, and I'll make the threads on the pads the same. I may as well use the original bolts because they're all tapped and everything. So all I've got to do is take these geezers out, which I will do. Does that fit? Yeah, these are almost finger tight. So I'll take these out, we'll have a look at them, and then I'll come back and show you making the pads on the lathe. So I've got the bolt out of, there's 3 of them in there. I've only taken 1 out, there's no need to particularly take those out at the moment, but what I've established, a quick measure and of the thread, that's BSF. It's the 5/16 BSF, which is 22 threads per inch. Now that's a bit of a problem because I'm just looking in my taps and dies drawer, which is down here. I've got a variety of sets of taps and dies. With regards to imperial stuff, BS sizes, I haven't got terribly many. I've got some more up there. I've got some BSF, funnily enough, but not this one. Now, if you can see in there, these are some really old ones I got years ago. There's things like 5/16 32, which is a model engineering. It says ME on it. Look, model engineering. So it's like a scale thread. I've got a variety of 3/16 ones in there, but no 3/16 by 22. That's 5/16 by 18, which is a standard Whitworth. 5/16 22 is the fine version, the BSF. So I'm going to have to get myself a BSF tap to do this, but I can still make the pad and drill it out to the right size. And we're just got to get ourselves a 5/16 BSF tap. Okay, quick sketch of what we're doing. It's basically a little mushroom. I mean, in profile it's going to be a pad like this, with a sort of back on it like that, which so there's a nice shoulder there. So this is the mirror here, and we'll stick it with the RTV sort of rounded up round the edge and round the sides like that, and in fact put some RTV underneath. What I usually do is just put a spacer underneath, and then the RTV can flow underneath as well. That's what I've done on other scopes I've done, and then that wants a tapped hole through it there, so that the it can go on the this will be the stud that comes out from the holder, and that'll screw up and down like that, and this will go in and out, and obviously allow collimation to take place. So the thing itself is going to be about half an inch top to bottom there, 1/4 of an inch shoulder on there, and then the hole wants to be 5/16 BSF, which look in my trusty Zeus book. Anybody that hasn't got one of these should get one. They're only cheap, they're about £5, and they've got every useful piece of information in that you could want. It's not Machinery's handbook, but there again it's quite quick to find things. Whitworth, there's BSF. BSF, there's the BSF section there. So look down here, and it's got let me show you. What I quite like about it is that it's sort of handwritten as well, which is quite quaint. So 5/16 22, which is the one BSF, has got a drill, outside core, tapping drills. Hang on a minute. 5/16 is a 6.75mm tapping drill. Yeah, it's down there. 5/16 6.75mm tapping drill. There you go. So this hole here wants to be 6.25mm. Did I say that? Or was it 6.75? BS 6.75, sorry, 6.75mm. So that hole there wants to be 6.75mm. So the size of this will be probably something based on the size of the bar I just go and find in my cupboard. Hang on a minute, let's go and see what we've got. I keep a lot of my stock. This is my bench, which is full of crap as usual, but underneath it here I've got cupboards with stuff in it, and I keep a lot of my bar stock and stuff in here. Now for an 8-inch mirror, I would have thought something around that diameter would probably be fine. It's probably a bit big, if anything. I wonder if we've got anything a bit smaller. Oh, we've got, that's a bit small. We've got to get, yeah, actually that's going to be fine. So we'll just take that chunk out there. I don't know what size that is, but that's going to be about right. I just remembered that these tools, these CRG tools tips that I use, These are the sort of general, these gold ones are sort of for steel and stainless and another material like that. And last time I was at the Auto Jumble, I was asking them about how you get a decent finish on aluminium, and they said, oh well, we do a special tip for aluminium, which is one of these, and they're really sharp. This is a sort of shiny tip, so I bought a couple and I'm going to give them a whirl. They've got a hell of a sort of relief on them. In fact, that's going to make the tip a bit high, I think, so we'll just try it anyway. We'll try it on this end and make sure it's get the centre height right, and I'll use it for this and see if we get what sort of finish we get on these fellas. Right, there we go. Is that tight? Yeah, it's tight. Right, let's put the tip back in the box. Right, so safety glasses back on. Right, so let's give this a go and see how it fares. Let's just see if it looks like it's on centre. No, it definitely looks high as that, so I'm just going to move it now by eye. So that's a bit of a nuisance if it's different centre to the other tip. That means that probably need to get another holder for these so that I can use them in here. Right, let's just touch off there. Wow, that looks pretty cool. Let me just put a smidge on there, a bit of jungle juice. Engage the feed, see what it gives. That looks like a pretty nice finish to me. Yeah, look at the shiny chips there. Have we got it on centre? Oh, an absolute country mile off. So maybe the centre isn't any different. Let's just get that centred. Look at the finish. Oh, that's really nice. I like that. That looks like at least that much. Let's try that again. That's a really nice fine cut. Let's see if you can see that okay. Let's see if we can zoom in on there. Still a little tip in the middle. One last little tweak. So we want to go up, don't we? So there we go. That should do it. I ought to get some lock nuts for these. In fact, I think I might have some. Lathe tools. I think these are they. Oh, I know what the problem is. Oh, actually, that one does go in. You can put those in and then tying that down now. There we go. Theoretically, that won't come undone now. So there we go. I'll leave that on there. Right. So one last cut on there. Oh, that's really fine finish. Lovely. Bit of squirt and get the main. 800 RPM by the way, and the feed rate is, I'll work that one out and tell you at the end, so have to look on the table, but look at that fine cut there, that's pretty nice. It's not breaking the chips, but I'm doing a very light cut. I mean, look at these things here, they're like gossamer. That got it, there we go. Back away from there, shut that down. Look at the finish on that. I don't know if you can see that from where you guys are. Nice, the finish is absolutely lovely. So yes, I approve of these. Have a hellish keen edge on them. Right, let's see what it's like at turning. So there's almost thread cut in there. There we go, this is the clean up cut along the bar so to make a couple of these Charlies. Get a nice finish on this with these tips. I'm really quite impressed with them. You can take nice fine cuts as well, which sometimes with with tungsten tips isn't possible, but these look to be really nice and clean and tight. Feed rate's probably a bit slow, but it's better. But when you're doing these shoulders, it's probably easier just to run a slightly slower speed. It gives you a bit more control. Straight up to there and wind back. So that's a very nice finish. That look, it's lovely, really nice and shiny. Right, so what we're going to do is we're going to have a 1/4 of an inch top hat section. So first things first, I'm probably going to drill and tap for the studs to go into. So let's just back that out. Right, so let's move in with the centre drill. Let's get the centre drill about there. There we are. Quick squirt of old of magic juice. It's pretty fast, but it'll be alright for finale. Get that goes in there. Right, what size do we want? 6.75, wasn't it? 6.75. So let's do 6.5 to start off. As well go straight for it. No point messing around. I don't know if I've got a 6.75. I might have to find an equivalent. So let's bang that in there. Right. This one, so that's 6. 6.75. This is a 6.8 because that's the closest I can find, which is the tapping size for, what's the tapping size for M10 I think, or M8, oh M8 sorry, it's the tapping size for M8, so it'll be lovely. Doesn't need to be a tight fit this at all. Right. Chap on the way in. Down now. Taking 1/4 of the mill off there, there we go, that's the bottom. That should do us. That's ample. Alright, get that out of the way. Right, so tapping now. I mean, sorry, turning this top hat down now. So we want this to be 1/4 of an inch, so let's just touch off here. Touch off. There we are. 0 my clock down here. So I've just touched off. I'm just going to 0 my clock at that point there, and I want 1/4 of an inch, 250 thou. So that's 50, 100, 150, 200, 225, 250. So there you go. So we'll just mark that there. So you see roughly where it is. What I'm going to do now is reset this to 0. And I'm going to move it, get it round to about there. So we've got plenty of sweep as it comes round. So I've now got this set to 0. Let me move you back. So I've zeroed that. Let's clean that off. so I know where I'm at. Let me just touch off the side. I'm going to put about 30 thou on for the first cut. All we've got to do is just watch the cut, watch the clock over here. As it approaches the cut here, look down at the clock. Clock's now moving, stop, and hit 0. There you go. So that's my, and I just double check that just to make sure. It's always worth checking because I have a habit of cocking up with these things. That's basically 250 thou. There you go. 2485. Clock it. I mean, this isn't very accurate doing this anyway, but 2470. So quarter of an inch, as near as damn it, quarter of an inch on there, according to the clock. I'm sure if I measured it more carefully, it would be better. And so just repeat, rinse and repeat. So another 30 thou. And I'm taking this down to basically down to quarter of an inch. There's a bit of glue on it. This time, getting a bit bored doing smaller cuts. Probably take a lot more off than that actually. Another big cut, and then I'm going to take a measurement. Right, I'm just going to take a measurement now, see where we're at. So 6900, I'm going to do it to 600 OD I've decided, so I'm just going to take 900 thou off there. So let's just do that in 2 chunks or so. So I'm just going to 0 this so I know where I am. He says, where is it there, 0. So 900, so if I do 450, that's a 450, there's a reasonably big cut. Put me within 450 of the end, so that's 6400, just over 6400. So I want 40 off. So from there, 40 is 10, 20, 30, 40. I'm just going to take it a smidge under, and I can just creep up on it. Not that it needs to be super accurate, this or anything. It's not got to fit anything. It just has to be the same as 2 of the others. It's always nice if they're the same size and they look the same size. It doesn't look quite so static. Right, so that should put us within a few thou. That's within 9 thou. Or 3 thou. I'll tell you what, let's get the micrometer out, let's do it properly. I know that you boys would like to see this done properly, so let's get the old mic out. Right, let's get that on there. Remembering that these are carbide tipped, and if you keep screwing you can get whatever size you want. That's 7 thou to go. So from there, that's about there. So that's about 7 thou. And this time when I get to the shoulder, I'm going to back out, so that I can clean up that face. I should have put some squirt on the remote for a decent finish. Here comes the 0. I'm just going to go a couple of thou past the 0, and then I'm going to back slowly out just to clean that face up. Okay. You can can see where I put the squirt on, because it's a better finish. Let's just get a rag and clean that up before we measure it. So let's see what that is. As I say, you keep turning and you can make it anything you like. I think I've gone over slightly. 59, well, 5935. Oh, 2.5 thou. 2.5 thou over. 59325. Yeah, haven't I? Never mind. It's a quarter of an inch. Oh, sorry, it's 600 thou as far as I'm concerned. Let's just do this again. Let's measure this shoulder again. I've got a depth mic somewhere, but that's within 4 thou, so that's fine. So all I've got to do now is tap that hole, which I haven't got the tap for at the moment. So what I'll do now is I'll chamfer these two edges, and then we'll part this off, and we'll just have an evaluation of where we're at. Ideally, I would like to tap them whilst they're in here, but I can re-chuck them against this shoulder and tap them back in the lathe when I've got the tap. So let's just stick a quick chamfer on there, just to clean it up and part it off. So with that tool, in with my Tom Lipton Special. This is the Tom Lipton tool that does chamfering on both sides, and back edges and everything everything in between. So just do that. WD. There we go. Just a nice chamfer on there, not too mad. Same on this one. There we go, nice chamfer on there. Let's see what that looks like. I don't think I've got this tool quite sharp or quite right. It's got in fact it seems to take bits of alley on the top. Yeah, and there's just a little sharp edge on there. So I'm just going to run a little file across there, just touch on there. Those two edges just seem to get a little tiny burr, and just a tickle with a file like that. That's smooth as a baby's bum now. That's much better. So just clean that up. Right, parting time. Ho ho ho! We love parting. Everybody loves parting. Out with that one, in with the parting tool. I don't know what condition this tip's in. I could probably do with a new tip in there. I've got one somewhere. I might get it. Make a nicer job of these ones. So, right, where we're going to part it off. Let's just touch that there. So the width, I think this is 88 thou. This geezer. So do that. Yeah, it's 90 thou basically. So I want this to be 1/8 of an inch, so it's 125 plus 90 thou, roughly speaking, is 215 thou. So I've zeroed it there. I'm just going to move put my magnetic clock on the way. I'll zero that. Oops. There we go. I'll do there. So I want to go 215 in this direction. So that's 50. 100, 150, 200, so what was it, 215, which is there. And then I'll just mark that. So, that's it, we're there. So, bit of coolant. Let's go. Rate of speed when you're parting, otherwise, especially in aluminium, it does. If you don't keep it on, it tends to dig. Depending on how rigid your setup is. I've got this tool quite a way out at the moment, but let me just clean that long chip off. You tend to get, sometimes the chips don't curl out right, and they jam on the joint a little bit, and with Ali it gets a bit warm, and before you know it, the tool's jamming. But we're alright here. and there's our part. Oh, a bit warm. So there we go. It just needs tarting up. I'm going to re-chuck it anyway to tap it from the other side right through, and I can clean up that as well. Unfortunately, this parting tool is one of those with an angle on, but the angle goes the other way, so it always leaves the remnant on the actual end that you want to use. I must get some tips which are the other way on, so you end up with the remnant on the end of this bar. It would clean up easier. What I did also forget is to chamfer that, but I can chamfer that when I put it in back the other way around. Right, I've just got it chucked up the other way around. I'm just going to clean up this side and give it a quick chamfer. Taking a really fine cut this way. It doesn't actually have to be that smooth because I want it to stick to the glass with the RTV. So ideally, you know, having a bit of roughness is no big deal. It's not the end of the world. Well, this is going to cook alright, I guess. We'll see, won't we? Might wrench it out of the. There we go. I mean, that's probably absolutely fine. Well, it's like a baby's bum anyway. It's smooth. Wow, it's so smooth that you can ski off it. I do like this bit. It does actually make a nice job. You saw that fine cut that was doing, and it is absolutely mirror finish. I'm just going to stick a little bit of a chamfer on the on there, just to basically just break the edges. It will stop it being sharp and nasty. There we go, in with the Tom Lipton chamfer special. Doo doo doo. Okay, I was a bit more ham-fisted there with the old controls, but that's lovely. So that's the fella done. So it just needs threading now, which I'll put it back in here to thread it. Oh, I just actually missed a bit there, didn't I? But you can see the finish there. It's really, really nice. A bit WD-40 and that shiny tipped insert. Very nice indeed. So I just need to make 2 more of those, and those will then be glued onto the back of the mirror, and the stud will be in here. Where's my bit of stud? You know what it looks like, and that should do the job. I've been telling you a bit about my mate John Wall. John is a very, very interesting chap, and has led a very interesting life, doing all sorts of engineering and stuff like that. Now the little part I've been making for sticking on the back of these mirrors is all part of the project I'm working on, which is a 24-inch telescope which he built in 1974. I think when he built it, it was the biggest amateur-built telescope of its type in the world. It's a slightly peculiar folded Cassegrain design, a bit like a Naismith, but without the axial or the viewpoint through the axis of the mount. But it's got tertiary mirror design, so it's not dissimilar to a Naismith, and it's a Cassegrain, but it doesn't have a hole in the back of the mirror, which makes it a little bit unusual for a Cassegrain, but that's because it's got its tertiary mirror arrangement. So anyway, John, a very interesting chap. Now, a lot of you probably haven't heard of him, but if any of you have got astronomical telescopes, you'll have definitely used something that he invented. Back in the 60s, he invented a way of focusing telescopes, and it's called the Crayford focuser. And the reason why it's called the Crayford focuser, excuse me, is because he lived in Crayford and he was a member of the Crayford Astronomical Society at the time, and he decided to dedicate the design to them. He was going to get a patent through the company he worked for. He worked for Vickers at the time, the armaments and instrumentation makers. And he decided that, I don't know the truth of the full story, and in fact I must ask John, and we must do a video of it because it would be an interesting story. Anyhow, he decided that he would build this design and he would set it free. So he published in the British Astronomical Society's in their journal,
he published the design, and nobody really was very interested. Then, much later on, I think it might have been in the 90s, the Sky and Telescope magazine, an American magazine, ran a little article on this design, just because obviously somebody had seen it and thought that's quite interesting. So they, all of a sudden, people started paying attention to this design. I've actually built one. This is actually one that I built for my 10-inch telescope, and this is a 2-inch design, so it takes a 2-inch eyepiece in here, so it's quite a big bore. And you can see that there are 4 holes in there. The way it works, there's 4 bearings that run on the tube, and at the bottom there's a plain shaft which is tensioned with a knob on mine on here. So there's a plain shaft running across the bottom of this tube. This is just a plain tube which has been anodized, so it's harder. And then when you turn the knob, the shaft moves in and out. Now it sounds like a really simple logical design. Until this design, what usually happened was there was a little bit of a friction pad in here, and it was all a bit sloppy, and consequently they would put rack and pinions in here, and they've got loads of problems. This is really elegant because it uses a big bearing, and my bearings aren't big enough really, but the bigger the bearing the better. Ordinary plain bearings, and this is just a hardened steel shaft which I got out of an old printer. Now I've made mine slightly more sophisticated. This is a 2-speed gearbox which I built, so if I move that, it's 1-to-1, so you can see it moving out fairly much in line with what you'd expect. The shaft is about 1/4 of an inch in diameter. If I turn this, this is a, I think it's an 8-to-1 gearbox, so it's 4 balls inside a cage with another shaft inside. So when you turn the balls roll. The balls are 4 times the diameter of the shaft, so you get a 4-to-1 reduction, and that gives you a fine focus. And the advantage of this design is it's backlash free. So that's one of the things that all focusers want to achieve, but none do. There's only the Crayford really that achieves completely backlash free. So when I turn that, it goes in of focus, out of focus, in, out, in, out. There's absolutely no backlash, and that is the beauty of this design. It's elegant, simple to engineer, and now pretty much every astronomical telescope on the planet has got a Crayford style focuser on there, and it's all because of my mate John, who invented it in the 60s. So that's the telescope that I'm repairing or renovating to fit into our observatory. It's a telescope which he built with his own fair hands back in the 60s and 70s, and I'm sort of modernising it, bringing it back to life. So that's a little bit about John. Hopefully I'll find some pictures and I'll put them on this video of some of the telescopes he's made. Not only was a 24-inch that I'm doing an interesting telescope, he actually went on to build some remarkable telescopes, one of which I think to this day is the biggest refracting telescope. That's one with lenses, the biggest refracting telescope in this country, bar none. So not even, it was bigger at the time. The Greenwich Observatory in London, which is very famous for its Greenwich Mean Time and all the rest, the Greenwich Observatory had a 30-inch refractor, so a big piece of glass in the front, 30 inches wide lens. John went and built a 32-inch, or it might even been 34, I can't quite remember, in his garden. Remarkable. Incredible guy. Hopefully you're going to meet him soon, because I'm going to go and check out his workshop and hopefully make a video of it for my channel. Anyway, thanks for watching this. I'm going to make the other 2. I'm going to get myself a 5/16 BSF tap, tap them all out, put them together. When I get to the glue stage, I'll probably show you the gluing, because it's quite interesting. I've learnt a few ways of making that work a little bit better. Once we've done that, we'll mount the mirror on there, and you'll see that the secondary assembly complete. And we should hopefully shave several, well, probably 2-3 pounds off the front, which will make a big difference to the balance of the scope, which I'm hoping to just want to lighten the front of the scope, because it just gives us more, excuse the pun, it gives us more scope when we come to put the thing back together again. So thanks for watching, thanks for subscribing, lots of subscribers. Thanks John Mills, Double Boost. Go to check out, if you don't know John, go and check out John Mills's YouTube channel, Double Boost. He's a great guy. He lives quite near me, north of where I live, and he gets up to some real antics. His videos are great fun, and thanks for recommending people to come and look at my YouTube channel. So I should reciprocate. Hopefully there should be a link to his YouTube channel at the bottom. So thanks, please subscribe, comment, like, all the usual stuff, and see you next time. Bye.